Okay, today is going to be our last day dealing with engines. We will come back to it later, but for now, I'd like to close it off with something very simple. So we've learned how to do all this stuff, but I'd like to show you a little bit of terminology that you should be aware of. Okay, so what we've been doing for the last few days is analyzing car engines. We looked at how it's best done using a PV diagram. And we saw how complicated the math could be. Not that the math itself was hard, but keeping it all organized was quite a challenge. So sometimes it's easy to talk about common transitions that you might see on a PV diagram. And these are the four: isobaric, isochoric, isothermal, or adiabatic. Isochoric is also sometimes called isovolumetric. Iso means one. So isobaric means one pressure. Isochoric or isovolumetric means one volume. Isothermal means one temperature. And adiabatic means no heat transfer in or out of the piston during that process. Okay, so there are four common transitions. So let's take them one at a time. This would be isobaric. You notice as we go from point A to point B, and I'll label them for you, that there is no change in pressure. Therefore, it's one pressure, isobaric. The way you deal with isobaric is the same way we've been dealing with it previously. We do work equals P delta V. The P is easy because it's one pressure, so whatever pressure we had at the beginning is the same as the pressure at the end. We then get our change in volume, we make sure we're in the right units, and we get our work. We then use the temperature of the two endpoints, and we find our change in kinetic energy. Finally, we take that change in kinetic energy and we find our heat. So isobaric requires you to do all three of these steps. It's the only one of these common transitions that will require you to do all the steps. Okay? Isobaric. This is isobaric expansion, so the work would be negative. If we had compressed the gas, the work would have been positive. Okay? Isobaric. This is isochoric or isovolumetric. It's a process that takes place at one volume. The volume does not change. So when we do work equals P delta V, this is going to be 0, which means the work is 0. Which means when we write kinetic energy equals Q plus W, the W is 0, which means the change in kinetic energy is solely due to heat that has entered or left our system. All right? So this, again, isovolumetric or isochoric. Work is 0. Volume doesn't change. It's a fixed volume. Okay? The volume of your cylinder does not change. Here is isothermal. Isothermal means one temperature. It is a perfect inverse curve. The way you can tell if your temperature is constant is by using your PV formula for a closed cylinder, a cylinder with a fixed number of moles. Okay, so nothing can get in or out in terms of particles. And then you just examine. So we have 600 times 0.05. Okay, and then we have some temperature. Then our pressure here is 200 times 0.15. And what you'll notice is that when you multiply these two numbers together, and when you multiply these two numbers together, you get exactly the same answer. Therefore, the temperatures must be exactly the same. Okay, if the top of our fractions are equal, and the fractions themselves are equal, these temperatures must be the same. So the way you check to see if it is isothermal is you do P1, V1, P2, V2, and you check to make sure that the product of pressure and volume does not change. It'll be a perfect inverse graph. And since there's no change in temperature, you have no change in kinetic energy. So it makes it super easy to deal with. Your change in kinetic energy is 0, which means any energy that enters as heat will leave as work. Okay, since this is 0, this plus this has to equal 0. So if heat went in, work came out. If work went in, heat came out. Equal amounts to keep the temperature and the change in kinetic energy 0. Okay, and that's called the isothermal. The last one kind of looks isothermal, but if you did your P1, V1 test, you'd find that the pressure and volume do not have the same product when you multiply them together. This is called adiabatic, and adiabatic means no heat gets in or out of your piston. If no heat gets in or out, it could mean that it's an insulated system, or it can happen so quick that there's not time for heat to escape through the walls of the container. Since Q equals 0, any work that goes in will turn into kinetic energy. Whatever work you put in will turn into kinetic energy. Okay, so we have 4 different processes: isobaric, isovolumetric. Isovolumetric, the work is 0. Isothermal, the kinetic energy change is 0. And adiabatic, the Q is 0. So isobaric is the only one where you got to do all your steps. All right? So hopefully if you could recognize these, you could save yourself some steps when you're doing your PV diagrams. All right, good luck.